Hello and welcome to Maths by SAS. This is my second lesson of D4 chapter number 5 exercise 5E, that is about the application of matrices in real world. Okay, in this lesson I will solve basic level question number 2. Question 2 says solve the following simultaneous equations by matrix method where possible. Where there is no solution, explain why this is so. Okay, in this question, the question which is given to us is having two simultaneous equations. In order to solve the simultaneous equations through matrix method, what we have to do, we have to transform every simultaneous equation in matrix form by writing the coefficient matrices, and then we have to associate some letters with that equation so that we can simplify and make it in form of simple algebraic equation, and then we have to solve that. Okay, let's move to the solution of the question. And as we have to solve the question by matrix method, so we have to write the coefficient matrices here. In the beginning of x we do not have any number, so it will be 1 and it's 3. Then from the second equation, this is 2 and this is 1, and then x and y, and that will be equated by the constants 6 and 4. Now let me associate some name with these matrices, like this is A, x equals to B, or in order to find value of x, what I have to do, I have to shift this A to other side, and equation will take the form x equals to A inverse and B. Now first of all, we have to find A inverse by using the formula that A inverse equals to 1 over determinant of A into adjoint of A. Now A has the entries 1, 2, 3 and 1. So determinant will be equal to 1 times 1 minus 6, which is equal to minus 5, and this is not equal to 0. For the system of equation to have the solution, it's really important that the determinant should not be equal to 0. 1 minus 6 minus 5. And now adjoint is a matrix. Okay, and recall the rule for adjoint, that adjoint can be easily memorized through PS. I have to change the places, swap the places of the diagonal entries, as we have 1 here, so we cannot find any change here, and we have to associate minus sign over here, minus 3 and minus 2. Okay, now A inverse will be equal to, 1 over determinant, which is minus 1 by 5 into adjoint, and adjoint has the value 1, minus 2 and minus 3 and 1. Now I have to find x equals to A inverse and B. A inverse minus 1 by 5 into 1 minus 2 minus 3 and 1, and B has the values 6 and 4. First, before going to the multiplication, we have to check whether multiplication is possible or not. This is 2 by 2 matrix and this is 2 by 1 matrix, because the columns of first are equal to the rows of second, so we can multiply the matrices. Now what I have to do, that I have to apply RC rule here, that rows of first have to be multiplied with the columns of second, that 1 will be multiplied by 6, and it will become 6, and 4 times 3 is 12, minus, and then 2 times 6 is 12 plus 4. And now solve the entries, that minus 1 by 5, 12 minus 6 is minus 6, and minus 12 plus 4 is minus 8. And now take this minus 1 by 5 inside the bracket, and this equation will take the form 6 by 5 and 8 by 5, as the numerators are larger than the denominator. So value of x equals to 6 by 5, or 1 whole 1 by 5, and y will have the value 8 by 5, and 8 is I can divide it over here. 5 ones are 5 and 3, and 1 whole 3 by 5. I hope you are clear about this question. And let's move to the second part. In the next part, the question says that we have to solve 3x plus 2y equals to 7 and 5x minus y equals to 3. Recall, in order to solve that the given set of simultaneous equations through matrix method, what is the first step? That we have to write down the coefficient matrix. So the coefficient matrix will be 3 and 2, 5 and minus 1, 5 and minus 1 into variable matrix x and y equals to 7 and 3. Now we can associate some letters with this so that it can take the form of some equation. Ax equals to b and x equals to a inverse and b. Now first of all, I have to find the a inverse. Okay, so and check whether the determinant exists or not. A determinant equals to let me make the line straight, 3, 5, 2 and minus 1, and this will give me minus 3 and minus 10. Let me reconfirm this. Minus 3 and 5 times 2 is 10. AD minus BC, which is equal to minus 13, and this is not equal to 0. For the system of equations, to have the solution or the inverse exists only when the determinant is not equal to 0. Now, for adjoint of A, recall the rule of adjoint, that we have to apply PS rule, places of diagonal entries minus 1 and 3, and signs of other diagonal minus 2 and minus 5, and close the bracket. Now A inverse will be equal to minus 1 over 13 into minus 1, minus 5, minus 2 and 3. Now A inverse is complete, and now I have to go for the product so that I can find the unknowns of the question. X equals to A inverse minus 1 by 13 into minus 1, minus 5, minus 2 and 3 into 7 and 3. Okay, the order of this matrix is 2 by 2 and this is 2 by 1. So the columns of first are equal to the rows of second. So we can multiply these two matrices and the resultant will have the order 2 by 1. So let's go for the multiplication. Minus 1 over 13 into, apply RC rule. Okay, RC rule, that take first row of first matrix and repeat with all the columns of second. Minus 1 multiplied by 7 is minus 7, and 2 times 3 is 6 with minus sign. Okay, with first row the column has been done. Okay, and now come to the second row. Minus 5 times 7 is minus 35 plus 9. And the question will take the form minus 1 over 13 into minus 13, and 35 minus 9 gives me minus 9, and this gives me 26, and 26 with negative sign. Okay, and now what we have to do is that we have to shift this scalar inside the bracket and simplify every entry with this scalar, and the question will take the form minus 13 by minus 13. This minus sign will be going, and 13 how many times? 1 times. And 26 by 13 minus 26 by minus 13, again minus sign goes with this, and 13 ones are and 13 twos are, and close the bracket, and this is equal to 1 and 2. So value of x equals to 1 and y equals to 2. Okay, very easy questions. And now we are learning the fourth method of substitution of simultaneous equations. Let's move to the next part, and in D part, now let's move to D part, and let me read the question from the book. Question is 3x plus 6y equals to 25 and 3x plus 4y equals to 17. Let's first write the coefficient matrix, okay, and transform these simultaneous equations into matrix form. Let me write the other equation under this equation. 3x plus 4y equals to 17. Now look, I'm writing the coefficient matrix here. 3, 3, 6 and 4. 3, 3, 6 and 4, and then I have to write the variable matrix x and y, and equals to 25 and 17. 25 and 17. And now let me give some name. Okay, associate some variables. Ax equals to b, and x equals to a inverse and b. This is the equation that we have to solve for the values of unknown that we are getting. Now I have to go for A inverse, and formula for A inverse is 1 over determinant into adjoint of A. And now go for the calculation of determinant, and this is equal to 3, 6, 3 and 4. Okay, product of diagonal, this is 12. 3 times 4 is 12, and then minus 3 times 6 is 18. Okay, take away 12 from 18, and this gives me 6 with minus sign, which is equal to 6, which is not equal to 0 with negative sign. Okay, and now I have to go for adjoint, and recall that adjoint can be memorized easily by what? By PS, that places of what? Places of diagonal entries. Swap the position 4 and 3 and write down the other diagonal as it is, and place minus sign before that. Okay, and now A inverse will be equal to A inverse equals to minus 1 by 6 into 4 minus 3 minus 6 and positive 3. Okay, yes, 4 at this place and 3 at this place, 6 and 3 at their places. Okay, now the time to go for x equals to A inverse and B, and then A inverse has the answer minus 1 by 6 into 4 minus 3, 4 minus 3 minus 6 and positive 3, and B has the entries 25 and 17. Okay, be careful while copying the data. Now the order of the first matrix is 2 by 2, and this has the order 2 by 1. Columns of first are equal to the rows of second, so we can multiply them. Okay, and let's go for the matrix multiplication carefully. That I have to apply RC rule. I have to take first row of the first matrix and multiply it with the columns of second. That 4 multiplied by 25, 4 multiplied by 25 is 100, and then 17 multiplied by 6. Okay, 17 times 6, 17 times 6, and this gives me 102 minus 102, and then 3 multiplied by 25 is 75, and 17 threes are 51. 51. Okay, now solve these entries. 100 minus 100, 02, minus 1 by 6 here, and this is minus 2, and 75 minus 51, and this gives me 24 with minus sign. And now what we have to do is we have to take this number inside the bracket, and the question will take the form minus 2 by minus 6, okay, and minus 24 by minus 6. And then I have to simplify this. Minus sign will be going with minus sign, okay. 2 ones are and 2 threes are. 1 by 3, this is plus sign, and 4. So value of x equals to 1 by 3 and y equals to 4 for this question. And let's move to the next part, and let me confirm the data with the book that in E part the given equations are 6x plus 7y equals to 4 and 5x plus 6y equals to 3. Okay, recall that what is the first step. First of all, we have to transform, we have to change these simultaneous equations into matrix form by writing the coefficient matrix, that's 6 and then 7, and from the second equation a coefficient of x is 5 and 6, and then xy equals to the constant 4 and 3 matrix. Then associate some letters like ax equals to b. We need to find value of x, so shift this a to other side. X will be equal to a inverse and b. Now we have to go for a inverse. Recall the formula that a inverse equals to 1 over determinant into adjoint of a, adjoint of a. Okay, and now we have to go for the determinant and recall the formula for the determinant, that we have to take product of diagonal entries. Okay, 6 times 6 is 36. 36 minus 7 times 5 is 35, which is equal to 1 and not equal to 0. So we can go for the inverse. And now adjoint of a, adjoint of a. So adjoint will be that we have to change the places of diagonal entries 6 and 6 and attach negative sign with other diagonal 6 and 6. So a inverse will be equal to, a inverse will be equal to 1 over determinant. As the determinant is 1, so I'm not writing it. I will simply be writing the entries of adjoint 6 minus 5 minus 7 and 6. Now what we have to do, we have to go for the solution of equation x equals to a inverse b. Now x equals to a inverse and b. X equals to a inverse. A inverse has the answer 6 minus 5 minus 7 and 6, and b has the answer 4 and 3. 4 and 3, let me, yes, okay. And then we can see that this matrix is of 2 by 2 and this is 2 by 1. Columns of first are equal to the rows of second, so we can multiply them easily. Okay, let's go for the multiplication. 6 times 4 is 24 and 7 times 3 is 21 with minus sign. Then minus 5 times 4 is minus 20 plus 3 times 6 is 18. Okay, let's quickly solve this, and this will give me 24 minus 1 is 3, and this is 18 minus 20 is minus 2. So x equals to 3 and y equals to minus 2. You can see that we are getting two intersecting lines and unique solution when the determinant of the matrix is not equal to 0. This is one of the important points to remember. I hope you are clear about today's lesson. Please watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.